Good morning, good afternoon, and good evening to everyone. Welcome again to SoBigData Digital Coffee, a shot of big data into innovation, entrepreneurship, ethics, and impact. I am Giulio Ferrigno, Senior Assistant Professor of Innovation Management at Scuola Superiore Sant'Anna, and I am very happy to introduce and moderate this webinar together with my wonderful colleague, Maria Giulia Garcea. We are so excited to continue this adventure with you. This is the second episode of this journey. Last time we discussed business transformation. Today we are going to talk about data-driven activities, turning data into successful innovations. But before we start, let me remind you the format. In every webinar, we always try to involve at least 3 different speakers, seeking as much as possible gender balance, but also representativeness of both academic and industrial world. The webinars are very interactive. Each speaker has 10 minutes to give a presentation, and at the end of the 3 presentations, we will have 15-20 minutes for a Q&A session. Therefore, if you have any questions, please write them in the chat. As last time, at the end of the webinar, we will read these questions, and these questions will be answered by our speakers. This session is also recorded on the YouTube channel of SoBigData. Therefore, you can follow this session also there. And just in case you miss any part of the webinar, you can always watch the recorded video whenever you like. Moreover, as promised, at the end of the webinars, you will receive a digital copy of the SoBigData magazine for free. Having explained the format, let me focus again about the aim of the webinars and the speakers. So, why are we doing this? Well, we're doing this because we want to spread some knowledge about big data by focusing the attention on very hot topics and by involving companies, academics, data scientists, or even policymakers. And last time we focused on business transformation. Today, we will try to understand something different. We'll try to understand how data can drive successful innovations. Indeed, in every corner of our lives, from the way we shop to the way we work, data plays an increasingly important role. It's not just about the sheer volume of data we have access to through our smart devices, cars, and appliances. It's more about what we do with this data, how we leverage this data to drive meaningful insights and generate benefits for our society at all. So data-driven activities are not just a buzzword, they are reality, they are the cornerstone of progress in the digital age. And when we are talking about data-driven activities, we are talking about more than just collecting information. We're talking about unlocking insights, predicting outcomes, driving tangible results. Think about it. With the right data and analytics, businesses can understand their customer better than before. They can tailor specific products and services to meet specific needs, anticipate demand, or even deliver personalized experiences. And it's not just about business, because data-driven activities have the potential to revolutionize many sectors, including healthcare, education, mobility, energy, and so on. So therefore, we cannot underestimate the power of big data in driving innovation activities. And to better understand this issue, we have involved 3 amazing speakers today. I'm very pleased to involve Malgorzata Nikowska to give you a policymaker perspective, Paolo Privitera to give you a company perspective, and also Paolo Ferragina to give you the university point of view. Thanks for being with us today. Now, it's time to go with the first presentation. I am very happy to introduce to you the first outstanding speakers of today. Malgorzata Nikowska. Malgorzata Nikowska is the head of Unit for Digital Transformation of Industrial Ecosystem, Directorate General for Communication Networks, Content and Technology, also known as DG Connect. She is also responsible for the set of the network of the European Digital Innovation Hubs. And she has started working at the European Commission in 2004. And so is almost 20 years she has working at the European Commission occupying various functions. Malgorzata, having you on this webinar's journey is a great honor for us. Today, we are talking about data-driven activities. So my curiosities are how many companies are actually using big data in their innovation processes, where we are in the digital transformation path, and where we should go, and what is the vision of the European Digital Innovation Hubs and the European Commission.
Good afternoon, Giulio. Thank you for these nice welcome words, and thank you very much for inviting me here for your webinar series. It's really a great pleasure to be here. So I will do my best to answer to your interesting questions. Let me first outline a little bit the background, the situation we find ourselves in today. So as you are aware, the current Commission mandate is coming to an end. If everything goes well, next autumn we will be facing a completely new Commission with new priorities. But this Commission, under our President Ursula von der Leyen, has put digital really to the forefront of all activities. We came up with the Digital Decade proposal, which set out we call them digital compass, so 4 cardinal points where we wanted to see digital develop most. And that was obviously skills. Basically, you cannot go anywhere and not hear that we are lacking IT skills or technological skills, whether you speak to universities, to companies, or to the public sector. Second cardinal point was the infrastructure. Obviously, to be able to use all the technological platforms that are out there and various tools, we need the solid infrastructure to be able to fully benefit from it. And the last 2 cardinal points refer to the really core of our economy, namely to businesses. So we want the businesses to be digital and really benefit fully from all the digital developments, and of course also our public administration. So the plan was great, the objectives were ambitious, but as we all know, you can plan whatever you want, you also have to implement it to actually see the results on the ground. And I'm happy to say that with the cooperation of our member states, we have a really solid process in place with every member state establishing their own pathway to reach the Digital Decade objectives by 2030, depending on their needs and on the current status that they find themselves in. And we monitor these developments. And in September last year, we issued the very first report of the Digital Decade. And let's say, mixed feelings. So on the one hand, we made a lot of progress, a number of regulatory and other measures were put in place, but we are not there in terms of where we want to be in terms of whether companies and other key stakeholders use and deploy the digital technology. So here I come to your question on how many companies, and I actually have an answer to this one, though maybe not in number. So according to our survey, 34% of companies use cloud, but only 14% of the companies use big data. So there is definitely a lot that can be done to increase the number. For those of you who don't know, our objective for 2030 is to have 75 percent of all companies using these advanced technologies. The situation is even worse for AI. Only 8% of the companies use it. Though I must say that the survey, the data was collected before the ChatGPT and generative AI craze, so possibly now the numbers would be slightly better. So we know that a lot still needs to be done on the ground, but there is one area where we really made a lot of progress, and that is data. Data had its own strategy. In 2020, we came up with the European Strategy for Data, which outlined very clearly Europe's objectives to increase our potential in the data economy and create a true single market for data. I don't have to convince anybody here that data is a key ingredient underpinning most, if not all, our policy goals under the digital decade. And to mention again, artificial intelligence, which is what everybody has been talking about recently, you cannot have artificial intelligence if you don't have data. You have to test your models, your algorithm on something, and you need data for that. So our objective was to really try to set up a more equal system, so that everybody, whether they are small or big, can benefit of the data simply. And in that context, we have came up with two legislative initiatives. One is called a Data Governance Act, and the other one, the Data Act, which has been subsequent. Both of them have now been adopted and are being implemented. So let me start with the Data Governance Act. It entered into application in September last year, and it aims to increase trust in voluntary data sharing, strengthen the mechanism to increase data availability, and overcome technical obstacles to reuse data. It does this by regulating, among others, the data intermediaries, so kind of a bank for data, people to whom we would trust with our data, that it would be treated in a way that it was designed to. Data altruism mechanism, so if somebody wants to give their data for whatever purpose to make it possible. And finally, the availability to reuse certain type of sensitive public sector data. As we all know, our public sector has a lot of our data, of companies' data, and this data could really be useful for certain developments. Building on this Data Governance Act, we came up with the Data Act as well, which is a complementary legislation. It entered into force this January this year, and now my colleagues are really working very hard on making sure it is implemented on the ground. It introduces new rights for data access and portability, enabling the development of innovative digital products and services, enhancing competition in the aftermarket products. And to facilitate this whole process, we are also working on the European data spaces. European data spaces are both infrastructure and contractual arrangements that allow certain parts of the supply chain or whole supply chains in certain sector to exchange data in a way that works for them. My unit specifically is currently having an open call for manufacturing data spaces. So if we have in our audience some representative of manufacturing companies, if you are looking how you can develop, share your data, get access to data that is in the possession of your suppliers or providers of sub-products, then don't hesitate to look into this. It could be an interesting opportunity to develop a way of exchanging and using data to the benefits of all companies. Data Act's rules on interoperability are another cornerstone for the success of these European data spaces, because they aim at ensuring seamless data exchange and collaboration across sector, which is of course vital for realizing the full potential of the digital economy. Not only manufacturing has a data space, also other sectors, and we are also putting in place a kind of umbrella structure called Common European Data Spaces, so that the various data spaces can also talk to each other and we can reap further benefits from this. So I would say that in terms of legislation and rules, we have done quite a lot and enabled this level playing field and a true single market. But as usual, the devil is in the details and in the implementation. Companies at this stage would have a little bit of difficulty to kind of figure out what exactly they can do or how they can benefit from all these various digital acts that are being out there. And to facilitate this, we have this network of European digital innovation hubs. They are one-stop shops helping companies with their digital transformation. And they are present in every member state, so any company can go to them, speak in their local language, and understand what specific European rules mean for them in practice on the ground in their country. They help any company, irrespectively of size, small and medium size, of course, as well as mid-caps in some cases. And even they can be of support to large companies, though the service potentially for that companies will not be free of charge, as it is in most cases for the SMEs. What the hubs do as a first step is really to analyze the needs of the company. It is they use a tool that we developed called Digital Maturity Assessment, and it has a very significant part, one of the 7 pillars, which is specifically devoted to data and how the company manages data. In that way, they can understand what the company actually needs. And as a second step, they can provide them something called test before invest, so that the company can test a given solution to see whether it works for them. And since my time is kind of running out, let me just give you one example, my absolutely favorite example of a Belgian company that produces a tool that enables to analyze in big buildings whether there is a leak of water. As we can all imagine, if there is a leakage somewhere that nobody notices, the costs and the waste simply can be enormous. This company has worked closely with one of our hubs, and the hub didn't help them specifically with the technology, but the hub helped them exactly with managing the data. Because while data collected from this sensor is not per se GDPR, so it's not personal data. However, still it is very sensitive data because it indicates when people are home. So they help them to manage the data and to protect the data in such a way that reassured the clients that these data will be safe and enabled the company to become more competitive on the market and sell more of their products. So to kind of conclude, we have the legislation in place, we have the rules in place, and we have the tools to translate this legislation into what the company needs on the ground. So there is nothing left for us than to really encourage the companies to use this and make the best of it and create the innovation out of data. Thank you.
What an incredible presentation, Malgorzata. Thank you a lot for giving us the policy maker perspective. Now, let's see another point of view, the point of view of companies. I am very happy to introduce to you all Paolo Privitera. Paolo Privitera is the lead data analyst at the ST Microelectronics, where he works within the quality and reliability group. He's also specialized in business intelligence and big data analytics at the University of Milano, Bicocca. And at ST Microelectronics, his team is responsible for providing advanced statistical data analysis, developing tools and algorithms to ensure the accuracy and efficiency of data mining, data analysis, and visualization processes of large volumes of data to support quality and reliability of products for customers. Paolo, thanks again for being with us today. My question for you is, what can data really tell? What are the innovation opportunities that companies might achieve in the big data age? Please tell us how many cool things you are doing at ST Microelectronics.
Yes, thank you, Giulio. Thank you for inviting me. Can you correctly see the screen?
Perfect.
Great. So let's start with some background information. Maybe you already know about ST. Maybe some of you doesn't know the company. It's a, let's say, very large company. It's one of the largest semiconductor company in the world. It employs something like 50,000 employees, and it's listed on the stock market. What ST does is microchip. So let's say it's the base for electronic device that we have in a day-by-day life everywhere nowadays. So you can, for example, open your smartphone. You will most likely find some chip produced by ST, even if I don't recommend to do it. But not only personal electronics, we produce also microchip for automotive, industrial products, laptop, and peripheral. So basically, chips produced by ST is everywhere, and is going to be more and more. So let's go further. As Giulio said, I work for the Quality and Reliability Division, which is in charge of course, analyzing and let's say certify the quality of the products that the ST produce. As you can imagine, the microchips are really high, complex technology products. So the quality is really, really important. And when ST produce one of the this device will be produced on mass production. So millions, thousands and millions of devices will be produced. So ST must be, of course, sure about the quality of the product they put in the market. If you want to be sure that your smartphone will last for 10 years, 10 years at least, we have to certify the chip that we produce. So we have to be sure that the products are reliable. How ST is sure that the product is reliable? They need to go through the qualification process. Why the qualification process is important, and why it's related with the topic of our presentation today? Because basically it's a process driven by data. So every decision made by engineers, by business is based on data. So if you want to be sure if the product is ready for the market, if there is room for improvement, all this decision is made by the data gathered during the qualification process. Not only the qualification process is important, but still we have to monitor the quality and the reliability of the process, the product during the mass production process. So you can imagine that we have a huge volume of data to analyze, huge information that we have to put in play together to extract insight and to take a decision. So that's why my team, the data analysis team within the Quality and Reliability Division is so important because we have, as I said before, huge amount of data, really high frequency of production of this data, and really complex analysis to do. So the context is quite challenging. You can see in these slides some numbers. We estimate something like 2 million of measure per day, 350 million of measure in a year. And this number does not include also the metadata that we collect and the data that we collect during the production phase. So you can imagine this data is basically a raw data. because the process generates millions of data during the testing phase of the product. Then the products are put under stress, which means they are putting in a condition of stressing to simulate the aging of the device and the wear out. Then they are testing again, and then they are analyzed. So it's a back and forth process, and this amount of data need to be cleaned, need to be checked in terms of quality, need to be fixed if there is any problem in terms of quality. They need to be aggregated, and then only after then is the data is ready to be analyzed with statistical methods. So the challenge for us is to, let's say, separate the noise from the value, we can say. So we have to extract the very useful information from the wide range of data that we collect. And how this process is done based on six pillars, let's say, which I gathered in this slide. And I will just spend a few words for each one. First of all, as I said before, we receive the raw data. So as I said before, we spend a lot of time to assess the quality, to measure the consistency of the data, to manipulate the data, and make sure that the data is ready to be analyzed. In many cases, this process is underestimated, but it's really crucial for the analysis. We can spend almost 70% of our time cleaning and collecting and put together the data and prepare for the analysis. But it's so important because if there is any issue, of course, the issue will affect the entire process. So we put a lot of time in this step, but it's crucial. After the first step, we can finally use statistical methods to extract value from the data. We have in place several algorithms. We go from the descriptive statistics to inferential statistics. So we have basic and advanced methods to extract value. The insights also have to be synthesized in reports, in data visualization approach to generate trends, distribution histograms. So, of course, our team need to have skills about the selection of the best visualization for the people that have to take decision based on this data. As you can see, these slides, all these steps, many of them are based on Python. So Python is a really important language that we use for analyze this data and extract value. And also along the line, we collect and store the information in a database, which is really important for us because we can have during the year the possibility to run some analysis at high level to understand how we are going, how the process is going, but also in a day-by-day activity, because we can use this information to put in place some automatic control and to help the testing and stressing phase with this data that we gather during the process. Finally, we have two other pillars. They are not core, let's say, but still really important for us. We had to develop skills also on user interface, because the many algorithms that we build to analyze and extract value from the data can be helpful for non-technical team. So it's important for us to create some interface for them that is really friendly and useful to leverage on the algorithm that we develop. And the first pillar is really important. I mean, it's not technical; it's more soft skill. But for us, in a data analysis team, in a company, I think it's really important to have. it's important to, let's say, interface with the business teams inside the company to translate their requirements into technical data analysis specification. We have to meet the expectations, so we have to be able to clearly define the deadline and to clearly define the expectation about what data can say to us, what insight we can extract from the data, and what is not possible to provide. So I want to also give some two examples about successful data-driven activities in ST to answer the question put by Giulio at the beginning. And let's start from Stable. Stable is an acronym for Statistical Bias Leveling. It's a project, it's a tool that we developed in ST to solve one specific problem. The problem was, as I said before, we have to let's say, test one product at T0, then put under stress the product, and then retest again the product after the stress to see if the stress in some way decrease the performance of the device. And of course, the problem is that when you try to measure one parameter over the time, of course, if you take the same measure over the time, can differ. It's obvious, no? We can't have the exact same difference over the time for the same parameter. But how can we be sure that the difference is due to the drift? So it's a decrease in performance, or is just difference due to different condition of testing, of measurement? In this case, to solve the question, many companies, what they do in this qualification process is to insert other device, similar device, but not put under stress, which are called the reference or control group. And they measure the same parameter over these devices to see if there is any difference due not to the stress, but to other condition. In this way, if we put from statistical point of view, in statistical terms, the question is, we want to see if there is any statistical significant difference between two independent distributions. What we use as a statistical method to answer this question is the unpaired t-test or t-student, and which requires to run two others inferential statistical tests as preconditions, which are Shapiro tests to see if the distribution are normal, and the other test is Levin test to see if the two distribution has homogeneous variance. This problem requires to run three different inferential tests, three different inferential methods over thousands of parameters in a really short time, near a real-time activity. And to solve this question, we developed the tool, which is developed in Python, as I said before, which is able to, in near real time, take the data we produce in input and run the inferential test and take decision on which parameter we are able to remove the bias, the systematical bias, and automatically clean the data. So the benefits is quite clear. We can, in this way, provide in a very short time more reliable data. And of course, we can reduce the misjudgment based on the data. We can, of course, provide more useful information for the teams that are in charge of improving the product.
Sorry, Paolo, if I interrupt you, can you just go to the conclusion, because we are a bit out of time and we are receiving many questions and we want to give enough space also for the audience.
Yeah. Just the last slides, and then the presentation is hand. The last use case is based on data visualization approach. We developed a Power BI solution to monitor in this way not only the data measure, but the process. So in this case, we use data analysis approach not only to keep and monitor the product information, but also to support the process, to keep let's say, keep tracing of the correct process and the correct, let's say, development of the process. So thank you for the attention.
Thanks a lot, Paolo. Now, the cherry on the cake. Let's see now the academical point of view. I am very happy to introduce to you Professor Paolo Ferragina. Paolo Ferragina is a full professor at the Department of Informatics, University of Pisa. He also served at University of Pisa as a pro-rector for ICT and also for applied research and innovation, and also has been the director of the doctoral program in computer science. His scientific works focuses on the design of algorithms and data structures for compression and big data research. He also received many awards, and the most recent one is the prestigious 2022 ACM Paris Kanellakis Theory and Practice Award. He's also been awarded by Google for a Google Research Award, and he's also authored more than 170 publications, 5 international patents, and also 5 books. So, Paolo, it's a great honor to have you on board, and thanks a lot for being with us today. We are talking about data-driven innovation. My curiosity is, did data type change in the last years, and the change in data has also changed the power of algorithms working on them, and which scenario has opened the new wave of generative AI?
So thanks very much, Giulio and Maria Giulia, for the invitation. So let me try to share my screen so that I can show my slides. Can you see them?
Yes.
Okay. So the title of my talk is clearly provocative in the sense that more data, in my opinion, means just more data. So we have to understand what is behind data and what we can do with data. But before going to the point, let me just make this statement that this is what actually happened in the last years, in the sense that machines are able to take decisions. And this impacts on our life in several issues and aspects, like we are influenced by machines, and this influence actually concerns with the interpretation and how we perceive the world and ourselves. And this kind of stuff actually worried us. And what we are worrying is how the machines are, in some sense, impacting or invading our life. And this was actually due to 4 pillars. If you open books or newspapers, you actually find 3 of them. And people typically talk about big data, HPC, and artificial intelligence. But since I'm an algorithmic person, I prefer to split the 2 and make a difference between algorithms and artificial intelligence that I consider totally different from each other. I have 10 minutes, so I cannot justify formally why they are different. But essentially, these are the 4 pillars that are driving this innovation and this change in our lives. And this change was driven, as I was saying in all, and it was clear from the previous talks, was driven by data. Data changed because several years ago, we were used about tables. So just lines, columns, and Excel files. Now data are at this form. And this form means actually that if you zoom in this, we could say, constellation of data, they have this structure in the sense that every datum, it's a point, it's a node, and also you have relations between data, so you have edges. And what we are trying to do when we are doing research or products is actually to create these networks of data. The more the data are connected and interconnected and labeled, the more the data becomes powerful. And this is my personal opinion. The change happened in 2012 when Google introduced what is called nowadays knowledge graph. And this was the original picture that actually was meaning that a graph, so you have nodes that here are shown by pictures of famous persons, so scientists, artists, or cities, and you have edges of several colors because every edge represents a different kind of relationship. And this graph allowed Google actually to change the interface of the search because you have not only the list of results, but also you have what is called the knowledge frame, what you read on the right. So you have information about Galileo Galilei, but what actually surprised us as researchers and actually users of search engine was actually the last part. Because Google was able also to show you not only information about Galileo Galilei, but also related people, related, let's say, celebrity, like Copernicus, Newton, and Kepler. And this was actually related to knowledge graph. Without knowledge graph, this was actually not possible. And the key point for this transformation and this innovation was actually twofold. From the one end, we needed to encode the knowledge, so more in a better way that was done before, and another way to develop different algorithms. So the knowledge actually consisted of a graph, a knowledge graph, and simplistically we can say Wikipedia. And the algorithm was called the entity linker. So just to give you an idea and don't show you any other kind of pictures, assume that you have a phrase like Leonardo painted Mona Lisa. These entity linkers were able to actually identify words like Leonardo and Mona Lisa and link them to pages of, we could say Wikipedia, but actually they were nodes in the knowledge graph of Google. And as soon as you do this mapping, and so you identify these entities, actually what happens is that you have these two nodes in the graph, and so you can navigate the graph. So if you think to Wikipedia, you could navigate to close nodes, and so you could do what is called inference nowadays, what is a semantic search. And so that if you were able, if you wanted to search for surrealism, surrealism was not present as a word in the previous phrase, but if you go to the node representing the page of surrealism in Wikipedia, or I would say any other knowledge graph, by measuring the distance of this node from other nodes close to Mona Lisa, Leonardo da Vinci, you could understand that there was a relation. This was the big jump at the time, so about 10 years ago, and this changed totally the scenario of search engine, and now actually we process data about graphs. So in PIsa, just to make some advertisement of the SoBigData platform, we are developing these kind of things, and we are contributing to entity linking. And we applied to several stuff, just to go to the end. We applied to link entities in text. We were able actually to improve the query understanding about user queries in search engines. Then I will describe this one because I probably became interested. We used these ideas to improve the news understanding by Bloomberg, London. And then just to know how this worked, we were able to pick a news, identify the entities in this news, and every entity was a page of Wikipedia that is shown in the right like balloons, pictured balloons. And for every entity in the news, we were able to actually identify links, so correlation between these entities. And by doing this correlation, we were also able to understand which entity was more important than the other. So we were able to actually classify, identify exactly what was the real topic of the news, because this was useful for trading, actually, to understand if a news was crucial for a trading or not crucial. But as I said, we had several other applications. In particular, we were able also to do analysis of experts, so expert finding, we call it. And so we designed about 7 years ago a search engine for, let's say, searching professors in the University of Pisa, depending on the topic. But what I want to tell you in the last 3 minutes that remain is the last wave. So the last wave was generative AI. So how these knowledge graphs are contributing to generative AI. So if you think to the work of biomedical researchers, they typically go to PubMed Central or PubMed, and these are huge repositories of articles. Just few numbers, they have about 10 million documents on PubMed Centrals, and more importantly, they are growing 1,000 papers per day. And so if they want to search these repositories, it's almost impossible to keep updated. So what we did was to define a new idea that is a search engine that actually goes to PubMed Central, extracts about 200 articles, and builds a knowledge graph on the fly on these articles. And then what was more important, we applied ChatGPT, I could say, so in general, any generative AI, to give an explanation of what the graph is saying to the researcher, just to simplify the browsing of the graph. And this actually you can access in this link. And so you will have the slides so you can check. And then also entered in the Google Cloud Innovators program just to make it, let's say, impactful. Just to give you an idea why this is important and what closes the cycle of my presentation. Because here and today, and you will see more and more in the next days, two technologies are converging. One is knowledge graphs that I described. The other is called RAG, Retrieval Augmented Generation. And the format of the search engines are now this one, in the sense that you have a user. The user poses a question. The question, so the query is sent to two kinds of archives. One is a graph archive, so a knowledge graph. The other one is a set of documents. You can think like Google, your personal Google. Then you combine the results produced by these two sources. And what you ask to ChatGPT is just to summarize these results. This is called RAG, based on knowledge graphs. And so what you want is an answer that is no longer a list of results, but is just a text that explains you and gives you answer. And this is a new wave because it's surpassing what are called the hallucinations by ChatGPT, because you are providing very vertical answers. Also improves fine-tuning. So all the limitations that search engines, LLMs are incurring, people think that they can be surpassed by this technology. And what is important is that you can play with this part that can stay private. So you can have a health database or whatever documents you keep in your computer, and you can exploit the ChatGPT just to make summarization. Or you could have an open source LLM in order to make summarization. So this is a very nice mix that tries to surpass, as I was saying, the limitations of OpenAI. And now all big companies are using graphs, knowledge graphs, and possibly in the next months also RAGs and this combination. And just to come back to my original slide, more data means just more data. But if you have proper algorithms and tools and platforms, probably they become also, they can talk to you and say interesting stuff. Thanks very much.
Thank you. Thank you. What an amazing presentation. Thanks. Now, let's move to the Q&A session. Let's scroll the chat and let's read some questions. So I'll start with the first one. A question to Malgorzata. Why do you think the number of companies using big data and AI are so low? Are there any forecasts for an increase?
Well, if I may paraphrase Professor Ferragina, data is just data. Yes, the numbers are low, but we should also look at our ecosystem of companies. In Europe, we have 90% of our companies are SMEs, and 90% of those are micro companies, so up to 9 people. Of course, some of them might be startups on the go, but the majority will be your local construction company, the hairdresser, a shop, manufacturing, things like that. These people probably never will use big data. They, on the other hand, can use data better. And I have one example of a bakery who started using their data and improved their competitiveness by knowing when to sell which type of bread. So even a really small company and not high tech at all can make use of data, but will it be big data? Probably not. Nevertheless, there are a lot of companies that could benefit from this big data and also AI and other advanced technologies, possibly technologies that today we don't know yet or are somewhere still in laboratories. And therefore, we have this setup of the European Digital Innovation Hubs. And the beauty of their approach is really that they respond to the company needs. So if a company needs AI, they will support them with AI. If they need big data, they will be supported with data. If they need a combination of those, that's the support they will get. And in addition to this, every member state has their own plans to help companies to go to this next level of digitalization, because clearly that's the future and that's where we want our companies to be. So there is a lot going on to support the companies, whether we really achieve our ambitious objective, 75%. I hope so. Thank you.
Thanks for your answer. Now we have two questions to Paolo Privitera. So the first question is, what are the challenges your company is facing regarding big data? And then the second one is about what kind of architecture did you run your process on? How do you arrange curated data? So this is something very technical. How do you arrange your curated data in order to enhance performances at the data visualization level? So please, can you answer to these questions just very briefly, because we are a bit out of time. And
yes. So very quickly, I answer the first question. I can talk about my division. I'm not aware what is happening in the other division in ST, but for us, the big challenge is to extract value from the big data and to put in place some cloud, let's say, solution. This is linked to the second question, because my architecture right now is not on the cloud, but is in a dedicated server. It's centralized server where we put in virtual environment for Python, but we are going to move to the cloud solution. At TL, yes, it's fully automated, but not with dedicated tool, but homemade scripts in Python. Data visualization is based on data marts. We created in-house data mart solution for specific use case of data visualization dashboard.
Thank you. Perfect. Now we have a question again to Malgorzata from Fatema. Sorry if I pronounce it wrongly. Regarding European data spaces, what are the projects in this space and what is the status on them? It's only Gaia X?
It's not only Gaia X. There are currently 14 European data spaces in various sectors: manufacturing, agriculture, transport, health, green. They are a little bit at a different level of development, but the first phase of setting them up started more or less end of last year. So this is still a little bit of the beginning, but soon or ongoing, we will have other calls. So if you are interested, please get in touch or look through our websites. There is lots of information there.
Thanks a lot. Now we conclude with the last two questions to Paolo Ferragina, Professor Paolo Ferragina. So a question from Valerie: what a good session. A question to Paolo Ferragina: will RAG substitute Gen AI? And the second question is, what are the limitations of ChatGPT and the systems you have just described?
So actually, the generative AI or all these tools like Gemini and ChatGPT and so on, they are a part of RAG. RAG is a new framework that actually includes ChatGPT as the last module that allows to, in some sense, rephrase or paraphrase the results. So, and therefore, it's a way of changing just the list of results into something that is human-like written text. So actually, the more you will improve, let's say, ChatGPT and all parents of ChatGPT, the more you can get advantage in the RAG framework. The last one, what are the limitations? The limitations, in some sense, with the RAG approach, you have all the limitations that also generative AI has, but they should be reduced in the sense that you should reduce hallucinations, you should make all affordable, because actually a very recent paper has shown that if you use the RAG approach, you can get better results with smaller models. So smaller models that have a reduced number of parameters so that you can just run on your personal computer. So, and about our system, a lot of limitations. So this is still in research status. Actually, we are searching for collaborations. So if there is in the audience anyone that is a biomedical researcher or a person interested in digital health, just send me an email, because we would like to test our knowledge graph for applications. So if someone is interested, fully open for collaborations. Thanks.
Thanks, Paolo. Thanks. Yes, indeed. Please contact us. Contact us if you want to explore new collaborations. We will facilitate the contact also with our speakers and also with the rest of the partners of the SoBigData research infrastructure. We could discuss for hours, days, or even weeks about this topic. However, this is a webinar where we want to just give you a shot of big data. Therefore, we have to close this session right now. But before closing, I would like to thank Malgorzata, Paolo Privitera, and Paolo Ferragina for being with us today. Personally thinking, I learned a lot today. And this is possible only thanks to the SoBigData research infrastructure. So a huge thank to Roberto Trasatti, Michele Natilli, and Valerio Grossi for letting me organize this webinar, also for supporting the organization of this webinar. However, this cycle of webinars does not conclude here. Let me remind you that the next webinar will be on the 10th of April. We will also address another important theme related to big data. We will talk about the ethics of big data. And this topic is especially important if we consider the AI Data Act just approved last Friday. But I cannot anticipate you more, but we are preparing something very special for you by involving also other outstanding speakers next time. The link, of course, will be the same. And for those of you joined us later today, you can always visit the SoBigData YouTube channel, if possibly make a like and watch the video again. The video will be out soon. Thank you all for attending this webinar, and have a lovely rest of the day. We look forward to seeing you again soon.
Ciao, ciao, grazie.
Thank you.
Thanks.
Thank
Thanks
you.
a lot.